So last time we finished the composition functions, right? Combining function and composition of function. Today we're gonna get into a new function called inverse function. Inverse function is one-to-one function. What does that mean? Is a one-to-one function? If the function is one-to-one, that means for every x value, it's corresponding to exactly one y value. And for every y value correspond to exactly one x values. Meaning what? You cannot repeat x and y's. Right? Yeah, no repeat of either x and y. Thank you, Mohammed. Now, if you look at the graph, how do you check if the function is one-to-one? Well, it has to pass through the horizontal line test. If the function is one-to-one, it has to pass the horizontal line test. Vertical line test what? Is this a function, right? So one-to-one function, it's better be a function first before it can be tested for one-to-one, right? So there are two things for one-to-one function here. It's a function and it's one-to-one. And it has to pass both vertical line test and horizontal line test. Now, where do I use one-to-one function in real life? You would ask, where would I use this? You actually use this all the time, you just don't think about it much. For example, I see a lot of people from different countries in this class, including myself, right? So a lot of time I exchange in my country money into US and vice versa. Right? It's used to peso and ruby and whatnot, right? So say let's do euro. Say €1 is equivalent to, last time I checked, is $1.07 USD. Now, if it's €2 will be what? The €2 equivalent to $2.14, right? If it's €3, equivalent to $3.21. Well, I don't want to keep doing that, right? I want to have a formula that I can change it back and forth. Right? So the formula will be, if I let X be USD, is the unit of American money, and Y be the unit of the euro, the European money, then the function will be X equal 1.07 Y. Makes sense, right? If it €1, is $1.07 in US, right? €2, 1.07 times 2 will be 2.14, right, etc. So if I want to know what is €30 worth in US dollar, so €30 here, and then times 1.07, I would get X is $32.10. So there's a function you can go back and forth, you change back and forth. You want to solve for X, is 1.07 times Y. You want to solve for Y, it'll be X divided by 1.07. Another one will be unit conversion. By the way, was I born? No, I was born, but I was very little. I heard, well, it wasn't me. Somebody told me that roughly 20-something years ago, US supposed to change to metric system. It's so easy to use, right? Everything is a factor of 10. It's so easy to use. Nowadays, I don't know how many ounces in 1 pound. English system, don't get me wrong, it's great and all that. It's just difficult to remember. Right? So sometimes if you import stuff from, say, China or Europe, they all use metric system. Only America and England, and I think one of the country in Africa use English system. Right? The rest of the world metric system. Right? So if you import stuff from other country, you might have to change back and forth. Right? And that metric conversion, say if I want to know what is a meter, I'm pretty sure an average American don't know how long is a meter is, but they know how long is a 1 foot is, right? So say 1 meter is 3.3 feet. And same thing, right? If I let x be the unit of feet, and then y will be the unit of meter, I have this equation where I can change back and forth. So 1 meter, replace y with 1, I have 3.3 feet, right? 2 meters, 6.6, etc. Celsius, convert in degree between Celsius and Fahrenheit. When I first came to this country, I have a hard time getting a grasp of the Fahrenheit degree. If you told me 65 degrees Fahrenheit, I would have not know how it feel like. I have to convert back to Celsius, because that's what my country used, right? And I got used to it. It took me like a whole year just to get used to the Fahrenheit unit. So for the formula, if you want to convert to Fahrenheit, you take 9/5. 9/5 is the same thing as 1.8 times the Celsius and add 32. So 0 Celsius degree will be equivalent to 32 Fahrenheit. Or if you want to convert from Fahrenheit to Celsius, is the inverse function. You solve for it. And later I'm going to show you how you find the inverse function. But if you solve for f, will be what? 59. 59 is the same thing. It's divided by 1.8 times the Fahrenheit minus 32. So see how because they are inverse function of one another. See how everything is reversed, right? Plus become minus, 9/5 become 59. So that's a few of the applications. There's tons of other applications. That's just a few of them. Right, so that's application. Now let's go to the theoretical part. We'll come back to the theoretical part. I hope you get a good idea what is inverse function is. So that when I explain to you in theoretical, you feel a little bit more, feel better, not like feel alienated by the function. Let f of x be one-to-one function that contain the set of order pair xy. The inverse of f. If f has an inverse, then the inverse of f denote f to the -1 of x is the one-to-one function that contain all the order pair yx. So as you can see, the domain and the range of f and f inverse is swapped. Right? If x is input of f, then x will be the range of f inverse. And if y is the output of f, then y will be the input of f inverse. They swap. You can see right here, they swap. Right? Input of f is x, and input of f inverse is y. By the way, f inverse, let me give you a little heads up here. Don't write this down. And it's not this part in black here. If I tell you 3 to the -1, then you would rewrite it as what? No, it's not a function. It's just a function. It's not equation. 1/3, right? Remember the rule, if you have a to the -n, if you want to get rid of the negative exponents, what do? You flip the fraction, right? I know a doesn't look like a fraction, but I can write it a/1, right? Or 3/1. So equal 1/8. to the n, or 1 over a to the n. That is notation of reciprocal. That is not reciprocal notation. That's the inverse notation. They look the same, but they mean differently. So be careful. F of -1 of x, it is not equal to 1 over f of x. Okay, because that's it. That's how the notation inverse is. It has nothing to do with the flipping. If you graph f of x and f inverse of x, then they're symmetric about the line y equal x. Let's take a look at this example. Can someone tell me what the domain of f of x by looking at it? -5, you start from -5, you include -5, right? That's a solid dot, 2, 2. And the range, yeah, the height will be from bottom up, bottom top will be -3 to 5, right? 5. The question is my graph is a one-to-one function? Yeah, it's past the horizontal line test, right? So it is one-to-one function. But let's graph. So we say yes, but let's answer first before we forget. Yes. If so, sketch the inverse function. How do I sketch the inverse of that function? You swap x and y, right? Swap x and y. So let's list out what is the pair x, y here in the black function. So this is my f of x. This point will be 2, 5. This point is -2, 3. This is -5, -3. All you do is just just swapping them. So 2, 5 become 5, 2. -2, -2, 3 become 3, -2. And then -5, -3 become -3, -5. And it is symmetric about the line y equal x. Grab that. If you look at the red graph, which is the inverse of f, we write f to the -1 of x. Can you tell me what the domain of f inverse? Yeah, -3 to 5. -3 to 5. And then the range? Yeah. You see how they're swapping? So if on the exam, if I give you the domain of f, you should be able to tell me the range of f inverse, right? And if you found the domain of f inverse, you should be able to tell me that's the range of f. You only 2 out of 4. Answer the rest. Now, we cannot just graph it all the time. It's not, especially you not be able to use your graphing calculator. It's not convenient, right? What if I give you just 2 functions without the graph, and I don't want you to graph it? Can you tell me are they inverse of one another? There's a way to check this, right? There's a way to check this. This statement said 2 functions f of x and g of x are inverse of one another if their composition equal x. What does that mean? You guys remember what composition is? Composition means you put a function inside another function, right? Russian doll, the thing Russian dolls. So if I would have take f composite g of x, if I would have rewrite this, let's rewrite this in terms of much more friendlier. So f of g of x, like that. I put g inside f, then my result should be x. And vice versa. If I do g composite f of x, or what I put f inside g, now f is the inside function, then the result also x. So conclusion, if f composite g of x is equal to g composite f of x equal to x. I mean, how many things you have to do here? You have to do two things, right? You're gonna put f inside g, and then again g inside f. Right? You do two steps, two processes. If they equal to x, then g is the inverse of f. That's what the in math notation, right? G is the inverse of f, and then f is the inverse g. Basically, the inverse of one another. Let's take a look at example 2. I want to show that f and g are inverse of one another. So I can prove two things. First, I can prove f composite g of x is equal to x. Right? Let me rewrite this more friendly way. That means that this implies it's the same thing as saying f is the outside function, and then g is the inside function, and it should be equal to x. And another one will be what? G composite f of x should also be equal to x. Or another way of writing this would be g now is the outside function, and f is the inside function to x. Well, I should have put question mark because I haven't proved yet. I don't know yet. This is what I want to show. Let's do the left one first. Let's do the left one first. Do you guys remember how to do this? So f, you start from inside out, right? You're gonna replace g of x by negative 8/5 x plus 16. And then what do I do with that negative 8/5 x plus 16? What do I do with the negative 8/5 x plus 16, the input? G of x or f of x? F of x. Because this is g, is already g, right? Remember the blue one is the f of x. So this is not the input of f, so you're gonna put it into f. I thought of blob, like I told you last time. So I look at my function f, I have negative 8/5 times blob plus 10, right? And that blob now is gonna be negative 8/5 x plus 16. So equal to x. Let's do all the way out. You're gonna distribute the negative 5/8 in there. So negative 5/8 times negative 8/5 will be x, negative x. And then negative 5/8 times 16. 16 divided by 8 is 2. 2 times negative 5 is negative 10. You can calculate if you want. Negative 10, and then bring down that 10 there, so plus 10. That one cancel. So it is x. For the second one, we do the same thing. Now it's just reverse engineering. So g is the outside function. The input is going to be the f of x. So I'm going to replace f of x with negative 5ax plus 10. And then we're going to shove that thing, the whole big thing into g, right? G look like negative 8/5. Well, it's no longer x, it's going to be that big blob. And plus 16 outside. So I'm going to replace x with a big blob. So negative 5ax plus 10. Negative 8/5 and negative 5/8x is x. Negative 8/5 times 10. 10 divided by 5 is 2. 2 times negative 8 is negative 16. Write it out one more time, like step by step. Maybe it helps you not making little mistakes. So we just show that f of g of x is indeed equal to g of f of x. They both equal to. So what is my conclusion? Yeah, the inverse of one another, right? So your conclusion would be g is the inverse of f and vice versa. If you don't want to write English, plain English like that, you can use this notation right here. I box in gray. It's the same thing. It's English. So far, so good. So if I give you two functions, I ask you verify this is inverse of one another, then that is a process. Now, what if I just give you one function and I ask you to find the inverse of it? I think you did this in 662 at least. Right. So this is just review here. The first step will be replace f of x with y. I'm going to walk through the step by doing the problem. So maybe it helps. So step one, I'm going to replace f of x with y. So y equal x cubed minus 4. Step two, swap x and y, or interchanging variable x and y. By the way, when you're swapping, you're always swapping the letters. Keep everything else the same, right? I see people just move the whole thing, x cubed, to the left here. You don't want to do that. Just the x, right? Just swap in the x and y. Everything else stay the same. So it's going to be x equal y cubed minus 4, right? I don't want to see this. Don't write this down. It's wrong. It's the same thing, right? Well, I mean, not the same thing, but it's wrong, right? Don't do that. You only swap x and y. Step 3, we're gonna solve for y. Any suggestions? Add 4, right? So x plus 4 equal y cubed. How do I solve for y? Cube root both sides, right? Cube root is the same thing, it takes to the power of 1/3. Whichever way you want to write, maybe cube root is more friendly. On the right hand side, the cube root and the root, cube root and the cubic function are inverse of one another, so they cancel. Remember what happened when the two inverse function cancel? What's left over? Just a variable, right? Just a y. And then cube root of x plus 4. And step 4, you're going to replace y with f inverse. RB, you try. When you took a cube root, you don't need to do x plus and minus like you do with the square root. Why is that? What's the domain of cube root? Is everything, right? As opposed to square root, only take what? From 0 to positive. Right. Yeah, thank you, Mohammed. Now, like I said, if you look at the cube root function, it looks like this. Don't write this down, it's just explanation. It's like a railroad track. This is the cubic function. Look like this. Right? And the cube root, you flip it around, it's a little bit more it will be narrow if you want, you will, right? Narrower. So the left one is a cubic and the right one is, I'm sorry, the left one is a cube root, the right one is a cubic one. If you look at both functions, so they're very easy going function. Right? When we take a cube root, we don't need to worry about plus and minus. But if you take a look at the y equal x squared, like this one right here, or rather, this is like I would say a steroid version of y equal x squared, right? Because that's translation, right? X minus 3 cubed. What is the range of this function? Everything has to stay above 0, right? Now, if this function is one-to-one function, no, right? Because it's failed the vertical, I'm sorry, the horizontal line test, right? In order to make this a one-to-one function, either you pick the left half or the right half, right? Pick one of the half. That's why when you take a square root, you have to put plus and minus to distinguish two equal halves. So now if I just pick the left half, now it is one-to-one function because it's past the vertical horizontal line test. And the same thing if I pick the right half. If the function is one-to-one, then it means it has an inverse. And if it has an inverse, it better be one-to-one. Those things go in hand, go together. So some function, you gotta restrict the domain. For example, I'll give you another example to write this down. Are you familiar with sine curve or cosine curve? Trigonometry. Well, you will soon. You will soon. So this is heads up, I guess. So this is a sine curve. Right, go on forever. Oh. And then on the same thing on the left, we're going forever. Kind of like that. Is that sine curve is a one-to-one function? No, right? So I kind of restrict the domain. So what in pre-calc, they're gonna restrict the domain from, they're gonna cut it off from here to here. So only that little portion in the middle, right? Or you can pick it, you don't like that piece, you can pick different piece, right? Some student can pick, say they like this piece. As long as it's past the horizontal line test, I'm happy, right? So for cosine curve and sine curve, if you want to find its inverse, you're gonna restrict this domain. Right, enough about those restriction function. Given big F of x equal x cubed, I'm sorry, x minus 3 square, and they restrict the domain here. I know a lot of time math students overlook that, but these are very important. Without them, I can't even find the inverse. Let's sketch the inverse function of f. We did this right in the beginning of the class. Yeah, we swap, right? Find 2 points. I suggest do integers, right? And then swap them. So I see 3 zeros. That means I have another one, 0, 3. And I see one more here, which is 0, 9. Right now I can swap them, become 9, 0. And then it looks like this. I know you don't know how to grab it yet. It looks like this. And it indeed symmetric about the line y equal x. On the graph, you don't see that line. It's not supposed to be on the graph, but it's nice to know that they are symmetric about y equal x visually. Now, I want you to find the red function. How do I find the red function? We just did it, right? We just did this process. Remember the process, swapping x and y and all that, solving for y. You do the same thing, the same thing. So step 1, let y equal x minus 3 squared. Why don't you do this? I'll walk around, see how you do. Practice that. Almost. Oh, no, sorry. Yeah, yes, but it's almost. Both of you. That's right. Yeah, like 90% right. And it's normal. I said right. Problem is 5 out of 5. I'll give you 5. Why? Remember, I told you this. A lot of times students don't even look at this restriction, but it's very important. X is less than or equal to 3. What does that mean? When you plug in, when you pick a number that less than or equal to 3, say 2, right? It's 2. 2 subtract 3 would be what? I don't care about the value, but it's gonna be what? Negative. Right? So that means that thing x minus 3 always negative. Well, the square become positive, but that blob inside the parenthesis is always the negative value of 0. So when I take a square root both sides, well, I'm gonna swap it first. So x equal y minus 3 squared. And then when I take square root both sides, of course, naturally I have plus and minus. Which case it is? Is it gonna be a positive case or negative case? Negative case, right? Because like I said in the beginning, x minus 3 always be less than or equal to 0, right? So your answer will be square root of x equal minus square root of, minus y minus 3. Parentheses, of course. Right. The square root and the square cancel, and then you have a plus and minus, but you told me to pick minus, right? So get rid of the plus. Minus square root of x equal minus y plus 3. I'm gonna move y to the left, so become positive y, and then move x to the right, or square root x to the right, so become negative root x plus 3. And last but not least, I'm going to replace y with f inverse of x. And this could be the big F though. Makes sense.
Can you put that negative outside of the y minus 3 because when we do our restrictions, it can't equal 0?
No, if you look at the restriction in the beginning, x less than or equal to 3, right? If you look at the original function, big F of x, if you can plug any value as long as it's less than or equal to 3, what is the expression inside the parenthesis going to be like? Going to be positive or negative? Negative, right? So it's always be negative, or at least 0. Because the only value you can be able to pick is less than or equal to 3. And that's how you're gonna have to pick a negative case when you take a square root. As opposed to the second one, I'll show you the second one where you pick the positive case, right? Because if you pick any number that is bigger or greater than 3, and then you plug it in here, it's gonna be at least 0, right? Or positive. So let's get the inverse function first. 3, 0 becoming 0, 3 again, same thing. And then I need to pick another one. Anyone you see? I hope it's 5, 5, 9, 5, 9. Right, so here 5, 9 become 9, 9, 5. 6, yeah. Thank you. 6, 6, 9. Become 9, 6. And then make it a little bit curvier. I like curve. Try not to connect like a straight line. Right? Oh, one of your exam, when you grab a quadratic equation, one of you make it look like a V, really like sharp V. I think I took a point off. Remember? No, I didn't, because there's only 1 point. It's only worth 1 point, so I feel bad. But please don't do that, okay? If other people grade your exam, it'll be a different story. Right? So just try to make it a little bit curvy. And it is symmetric about the line y equal x. Try the inverse. Oh, this one easy, right? This one when you so let's swap x and y. And then now you solve for y, you take a square root both sides. Plus and minus. Two plus k. Let me write it here. 2 minus k's. On your notes. Well, we don't usually write plus, in parentheses y minus 3. We don't write anything, it means that it's plus. Solve for y equal square root of x plus 3. It makes very much sense. If you look at the graph, let me go back to the very beginning. If you look at the graph, let's pick some number. If x is 0, I got what? I got 0, 3, right? If x is 9, oh, we're gonna use plus and minus. Depend on what restriction you are given. So for case A, for 4A, I'm sorry, for number 4, the restriction was x has to be less than or equal to 3. If you pick any number that less than or equal to 3, say number 2, you plug into the function f, the quantity x minus 3 is always what? Always negative. Right? Because 2 minus 3 is negative 1, right? 1 minus 3 is negative 2. Even 0, even 3 minus 3 is 0, right? So the largest value it can get is 0. Okay. And 0 is neither positive or negative, so we don't care about that. So when you give the restriction that is less than or equal to, and you plug into the original, if the quantity inside the parenthesis is less than, then you're going to pick a negative case, and vice versa. Right. You're welcome. Where was I? If I pick x equal 9, what happened? Square root of 9 is 3, minus 3 plus 3 is 0. If you pick x is greater than 9, say 10, well, square root of 10 would be 3 point something, right? It's going to be negative 3 point something. So your graph is dipping down to what? The negative value, right? You see, if you look it over, it's negative, right? So it makes sense. Let me show you the decimals. Maybe better than me. Keeping talking about. Question 3.8. So that is the original f of x. Here is the inverse. You see how I write it in my code is x equal f of y, inverse. And for the second one, I don't want to see that. I'm gonna get rid of that things. I cannot touch that thing because oh good God. All right, come on, let me touch it. You know what? Here, I want to do this. There you go. There you go. Right. So that's our number 5. Number 6 is you try to. 6. I'm gonna do number 7. We're gonna do number 7 together because it's harder. Unless you want to do number 7 for you try to. It's slightly harder. It's not too hard. It's slightly. Maybe it's something you see on the exam. Because I'm not writing exam 2 this time. It's Tom. Tom, other instructor. No, he's nice. He's been teaching for a long time, so he knows a lot more than I do. in terms of like experience with student wise. Right? All right, what is the step when I find the inverse? Step one, we're gonna replace f of x with y, right? Or in this case, g of x. So y equal 5x plus 4 divided by 2x plus 3. Swap x and y. How many y value you see here? 2. That's what I said, a little bit more complicated. Just slightly more, not too bad. Oh, that'll be y. Now I need to solve for y. One of them is the denominator. I need to bring it back up. So what is the LCD for this rational equation? So multiply both sides by 2y plus 3 over 1. I like to say over 1. And then you distribute that. To the left-hand side, it's going to be x times 2y plus 3. My parentheses are too big. On the right-hand side, it's cancel. That's what we want, right? It has to cancel. You can, yes, you can cross multiply. But be careful. You only be able to cross multiply when what? When you have one fraction on the left and one fraction on the right. Right? So if I have two fractions on the left, say x plus something else, then you cannot do that. Okay? What should I do next? It looks like I'm making it more complicated than it should be. But it's not, right? Let's distribute the x, see what I can do. So be 2xy plus 3x equal 5y plus 4. Can anyone see anything? No, I don't want to take the x out and now go back up to the other, go to the previous line. Yeah, group the y together, right? Group the y together and move everything that doesn't have y to the other side, right? So I'm gonna move the 3x to the right side because it doesn't have y inside it. So minus 3x minus 3x. That's canceled. What else? I'm gonna move the 5y to the left. So subtract 5y. Subtract 5y. So on the left hand side, I have 2xy minus 5y. Don't combine them. They're not be able to come. They're different terms. Equal to 4 minus 3x on the right hand side. Everybody okay with that? Now I can factor out the what? The y, right? So that is a technique. If you have two y's, that you're gonna figure out the way how to put them together and factor out the common y. Divide both sides by 2x minus 5, 2x minus 5. Cancel. So y equal 4 minus 3x divided by 2x minus 5. And don't stop here, there's one more step. G of inverse of x. I'm lazy, so I am. problem 6 should be very easy, very straightforward. I read large. What is the domain of F? I'm sorry, G. Keep saying F. How about G of X here? What is the domain of G of X? You know how to find the domain of a rational expression? Everything but what? Negative 3/3, right? So the domain will be everything. So here x is not equal to negative 3/2, right? And you have the right in interval. That so we use parentheses. Union, what? Yeah, negative 3/2 to infinity. Do I know the range of G by looking at it? No, right? Unless you graph it out, which I don't want to do this, right? Remember how hard it is to graph a rational function. So we're gonna wait. We're gonna wait. Now let's find the domain of G inverse. Bless you. What's the domain of G inverse? Yeah, x cannot be 5/2. And then you write it in interval notation. Negative infinity to 5/2 union 5/2 to infinity. Now you can swap them, right? You have domains of each of the function you can swap. So the domain of the G of X in black right there will becomes the range of G inverse. So basically all you do is copy the thing being marked in gray. So the range this one. Range box in red. And then what is the range of G of X? Right here. Right here. All you do is just rewrite it. You don't have iPad, rewrite it. Like I said, you only need 2 out of 4. Try the rest. Yeah, you try, you do the same. Part A, you're gonna find the inverse. Part B, I don't remember how many parts, but you find the domain and range. I think 3 parts. Yeah, domain and range of F and domain and range of F inverse. Let's do number 8 and then we'll call that a day. I'll ask Sarah to do number 9 in your workshop. Find the domain of the function f of x. Here the step. What is the restriction on the domain? Let me write it down. Because square root only takes is only defined is only defined when what? When the quantity under the root, right? Quantity under the radical is non-negative. Remember that, non-negative, right? So that's imply whatever underneath, which is x minus 3 squared times x plus 4 divided by x minus 1 squared has to be what? Greater or equal to 0. And you gotta remember how to do this. Step B, find the 0 of the numerator and denominator. So we're gonna let x minus 3 equals 0, imply x equal 3. We let x plus 4 equal 0, imply x equal negative 4. And x minus 1 equals 0, imply x equal 1. Mathematicians call those the critical numbers. What you're going to do next is you're going to put those critical numbers on the number line. So I have negative infinity at both sides. I don't care about the scale as long as I put in the right order. So negative 4, 1, and 3. Can I have a solid dot at negative 4? Look at the function. Yes, right? 0 is okay on the top, right? So at negative 4 and at 3 is okay to have a solid dot. If it's negative 4 or 3, it's going to have 0 on the top and which is okay. What about 1? Should I put hollow or solid at 1? Hollow, right? Cannot take 1. It'll make my denominator equal to 0. How many intervals do I see here? 4, right? If you have 3 critical numbers, your number of interval will be 1 more. So 3 critical numbers, 4 intervals. And then test point. You can remember this? Any deja vu? Between negative infinity to negative 4, I'm gonna pick negative 5. You can pick anything you want as long as within that range. Between negative 4 and 1, my favorite is 0. You can pick negative 3 you want, but let's pick 0 to make our life easy. Between more than 3, pick 2. Between 3 and infinity, pick 10. What I'm going to do with those yellow numbers that I picked, I'm gonna plug into that I'm gonna plug into here. To here. I don't care about the value. It's the size that I care about, right? So I'm gonna do 1, and then you understand, right? Let's plug 0 in. 0 minus 3, but the 3 is square, right? So it's positive. 0 plus 4, that's positive. And then 0 minus 1 square is also positive, right? So here I have positive. And you keep doing so, right? You only give it a happy ending. Minus positive, positive, positive. Which interval am I picking? The positive one, right? Positive one. So my final answer, and I'll let you go, will be negative 4, 1, bracket negative 4, comma 1, parenthesis, union, parenthesis 1, comma 3, bracket, union 3, parenthesis, I'm sorry, comma, infinity. So the 3 included, so you can pick, it doesn't matter, I'll take either or. Have a good one, and I'll see you again on Wednesday. Sarah will do number 9 in the workshop. Text her.